Thank you very much. Can you hear us? Yes, excellent. Yeah, so lessons learned writing Kubernetes operators. The writing was mostly done by ourselves, and Jannik did the actually using it. And yeah, so who are we? My name is Lars Francke. I'm the CTO of a company called Stackable. And
yeah, I'm Jannik Heyl. I'm business unit lead of big data and analytics of Evolar. Sissy.
And
yeah, let me briefly introduce the Evolar to you so you understand the setup. We are a consulting company with over 300 experts, mainly located in Germany, but we also have subsidiaries in Austria, Switzerland, and so on and so forth. We originate from software-defined data center, where really early in cloud native did a lot of Cloud Foundry, but also Kubernetes. We did we're doing hyperscaler, a lot of networking, obviously big data and analytics, since I'm the business unit lead of that, and we are also doing software development. So that's a brief introduction of what we are doing.
And we at Stackable, we are building a data platform on top of Kubernetes. Kubernetes is the only bit missing in this graphic, but all of it is on Kubernetes. And for all of these tools, we've written operators, and this is what this talk is going to be about, basically. So all our operators are open source. All of these tools are open source. I'm sure you know some of them. We are around 20 people, founded 2020, right here in Wedel, close to Hamburg. So we are local, and well, you might ask whether we are insane, because if you look at these, there are definitely already operators for some of these out there, but we do have a good reason why we wrote all of them again on our own, and this is where Jannik comes in.
So why are we as Evolar using Stackable for our data platforms? To understand that, first of all, we have to explore for what reason or for what use case we are using Stackable. So we have to understand how a data lakehouse works. A classical database, like Postgres, for example, has 3 jobs. The first job is data persistence. The second job is data management. And the third job is data processing, or also known as querying. The pros of this system are, I think, well known since the 80s, but we have a single, easy to install, easy to maintain system. So we have like a single binary, a single container image, and off you go, and you can do whatever you want to do. You can do OLTP jobs on that, you can OLAP jobs on that, and those databases are stellar for the job they are written for, so they work really well. The cons of these databases comes when you want to implement a central data management system or a central database that consolidates every data in a company. The problem is that classical databases persisting data is massively expensive. This is because there is a linear relationship between the amount of data you can store and the amount of compute power. Or if you double the amount of data you store on a Postgres instance, for example, you more or less have to double the amount of RAM and CPU the Postgres instance has. Also, these kind of databases have one paradigm at a time. So you can choose between relational databases or various NoSQL databases, but those databases cannot be both, right? So building a central data management system is hard because you cannot save all the data because it gets really expensive. You have to pre-process a lot, which is really tedious. And in the end, you have to have multiple databases. And if you have multiple databases, you also need a querying layer above those databases, which gets also pretty hard pretty quickly. Therefore, we have, smart people came up with the idea of a lakehouse. So what is a lakehouse in one sentence? In one sentence, it's the 3 jobs that a database does: storing, managing, and querying data, divided into multiple independent systems. To make a bit more sense of that, I will talk you through 2 queries for an example with this made-up architecture. So, for example, think of insert query. Somebody inserts data into a table. Then this insert query is processed by the data transformation layer. And what the data transformation layer does is it asks the metadata store, is this table even existent? If it is, it checks the schema, and if after checking the schema, it checks if the schema of the data that should be inserted is valid against the definition in the lakehouse. After that, the data gets stored in Parquet files in storage. This is object storage, for example, S3, really cheap and really scalable. And the last thing the data transformation layer does is updating the metadata store, so the metadata store knows that there is a new file for that table and where it can be found. When another user queries this table, the query engine on the other hand side looks in the metadata store for the table, looks for the files that are associated with that table. The query engine downloads all those files from S3 over a classical file download and then queries this data completely in memory. So this is how a lakehouse works. What are pros? Storing data is crazy cheap. Why? Because you only need the processing power, the querying power that is actually needed at the moment. So if you don't have any queries running, you don't need a query engine, right? And if you have a lakehouse that has maybe 100 petabytes of size, and you just want to query a table that has 100 megabytes, you can do that with a Raspberry Pi or your calculator. You don't need like all the processing power to process like 4 terabytes or 4 petabytes of data. Also, we can have multi-paradigms in a single system. So you can switch out different components depending on the use case. You can add, obviously, more data processing tools in the long run. Also, this is something that customers ask us a lot of times is how fast are these systems? These systems are, for analytical processes, for OLAP queries, as fast as classical distributed databases. They get, and this is really slow if you have like OLTP use cases on that, or if you have a lot of really small queries, as you can imagine. Another con of a lakehouse is that the architecture is complex and has a lot of components, and this is where Stackable comes into play, and this is also the reason why Stackable is developing all those awesome operators, because if we would take all the OEM operators of these technologies, you would have a real mess with custom resource definitions that are different, with different monitoring capabilities, with different backup capabilities, with different logging capabilities. Security is a topic, so how do you provide that across the tool chain? And what Stackable did is building all those operators with a standardized way of using them. And this makes implementing and maintaining a data platform much easier. And this is also the first topic that Lars will go on about later, that the operator pattern is in that sense more a bit incomplete, since it describes how an operator works, but it doesn't set standards and convention on how database operators should work. And everybody of you who used multiple database operators will know that the look and feel of those operators differ quite significantly. And that's why we are using Stackable.
And now to the actual lesson learned bit. So you now learned why we did what we did. And so I'm the co-founder and CTO of the company. So naturally, I haven't touched a single line of code in 2 years because I haven't been allowed to by my team. But I've collected, thank you. I have collected these things, and I can probably also answer questions at the end. If not, yeah. So build a data platform on Kubernetes, they said. It will be fun, they said. Well, it turns out it was quite an adventure. So we started 2020, and we looked at around 30 different operators out there. And one question, who here has already written a Kubernetes operator? Holy crap, I hope I don't insult any one of you, but most people have written like one operator. Some have written 2 operators, and we found that very few people, if none, have written 10, 12, or 13, or I think we might be up to 14 or 15 by now. And we found out that they are all pretty inconsistent, so that's our first lesson learned. So we looked at all of them and said, there must be this best practice standard thingy that we can look at. Turns out the answer is no. There are things like the Zalando Postgres operator that are popular, the Strimsy operator, and so on, but all of them operate totally differently. There's very little standards out there, and it turns out that some things are pretty hard when you go above 1 or 2. So let me ask again, who's written more than one operator? Okay, that's more like what I expected. Who's written more than 10? Okay, excellent. Yeah, so I hope some of the things that I mentioned will actually be useful. Yeah, so this is what we found the big problem with operators is. It's not the technology. Kubernetes is okay-ish most of the time, but the problem is like standards, finding out what works, what doesn't work, learning on the job basically. And there's so much to learn. I mean, I don't know how many releases do we do per year now, three releases, Kubernetes releases per year, new change logs, new release notes and whatnot. A new project, I'm sure a new project has been launched during this session already. There's new technology coming online all the time. It's really, really hard to keep up, and that's fine. So my background, maybe I'm like open source contributor. I'm a member of the Apache Software Foundation, committer for HBase and Hive and so on. So I have a technology background, but it's really, really hard to follow all of these projects. Like when I was an open source contributor, it didn't matter. I did it for fun, but now we're trying to run a business here, so we have to be a bit more stringent. So this is hard. And the first thing, or second thing, so first thing we learned, no standards, no like conventions. I'll get to that later. Second thing, there's not a good community out there to talk about operators. There's the Data on Kubernetes community, for those who might know. There's some channels on the Kubernetes Slack, but it's like there's not really a community to talk about operator design. Next thing, so this is a random assortment of like junk that we learned, right? So this slide has no connection to the previous one and so on. And I might not get through all of them, so we'll see. So the next thing is, when you Google for operators, you find Operator Hub. I'm sure lots of people here have seen it before, right? I see some nodding, some puzzled looks. Anyway, so if you Google for Kubernetes operators, you will find this page. And we thought, excellent, that's a well-maintained catalog of operators that we can look at for like best practices. Turns out the answer is no. In the About section, it says it was launched by Red Hat. I know some Red Hat people are here. Sorry for that, but it was launched by Red Hat, Amazon, Microsoft, and Google. So we reached out to Red Hat and said, hey, what's the deal? Lots of these things are outdated. There's at least one trademark violation, even on this page that you see here now. What's the deal? Who's maintaining this? Red Hat says, it's not our site. But, okay. Anyway, so this sucks. So we don't have a good catalog of up-to-date, well-maintained operators that people can look at. At least that's our opinion. There are some out there in this catalog that are good, but most of them haven't been updated in years and they don't work and so on. So this is the next thing that we learned. Again, goes back to the missing community. It was really, really hard to find people and to find good operators to look at. The next thing that we looked at, again, totally different from the previous one, is writing an operator. There's this thing called operator SDK. So of those people who have written an operator, who have used this operator SDK? Oh, that's not as many as I would have expected. So the operator SDK is, again, a project. I don't actually know if it's a CNCF project. Some of you might know, I don't. It's a project out there that, yeah, as it says here, makes it easier to build Kubernetes native applications or operators. And we thought, excellent, let's use that. So we looked at it in a bit more detail, found out that it can write, you can write Go, Helm, and Ansible-based operators using it. So Helm and Ansible, okay, weird, but anyway, works. And Go. So, okay, we looked at it. What does it do? When you start a new operator using this SDK, it has a CLI. You can start building an operator. What it does, it's templating. It generates a bunch of scaffolding for you, and that's it. As far as I can say, and this was last we looked at it around 2 years ago, so my information might be a bit outdated. But last we looked at it, that's it. It builds like a scaffolding thing for you, and then you're more or less on your own. It has a few CLI methods to create a new object and so on, but it doesn't help you at all building your operator after that. Like, what does a reconcile loop look like? It doesn't have any functions that help you implement common functionality and so on. So that was a bit, to be honest, underwhelming for us. And by the reaction of the show of hands here, we had maybe 20, 30, 40 people raising their hand earlier, and maybe 5 to 6 using the operator SDK. Other people might have made the same discovery. So what we did is something that 2020 was a bit, well, weird maybe, but first one step back, we as a company, none of us knew any Go. We didn't know any Go, so we knew that we would have to learn a new language anyway. Most of our background was Java, and we were pretty certain we didn't want to write an operator in Java for reasons I'm not going to go into. I don't have enough time for that. But what we did instead is we picked another language that we have never heard of before, which is Rust. And we have developed our operators in Rust, and we've been really, 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 really happy with that. So Kerberos is the official now CNCF sandbox project to access Kubernetes from Rust project, and it's been awesome. The biggest reason we've chosen Rust over Go is now also outdated. Go didn't have any generics back then in 2020 when we started, and we knew that we wanted to develop a lot of operators, like 10 plus operators, and we knew that we would have a lot of common functionality. And that is just perfect for generics. Like, we extracted so much generic code. If anyone has looked at the Kubernetes source code itself or source code of some of the operators written in Go, you will see a lot of casting around to pod objects and so on, and that's just crap. I'm sorry, but that's just like that's not nice in my view. And again, it's very subjective. So we've been using the Rust library, Kerberos, and it's fabulous. It extracts so much stuff into generic functions that you can reuse. We were able to hire one of the 3 maintainers of the project, so that's obviously awesome for us because we can, whatever is missing, we can contribute back. And there were a few things missing. One has bitten us in the ass quite bad. Like, it didn't have support for admission webhooks at the beginning, for example, which means we couldn't do CRD versioning properly and mutating webhooks. So we couldn't do CRD versioning, which sucks, but it's been implemented now, and that's awesome. And the maintainer is awesome. Everything is awesome. So I can wholeheartedly recommend writing operators in Rust. It's great. It's been a great experience for us, and I know that it's not, not everyone is of the same opinion. I'll happily take questions and insights on that later. So the next thing, I want to talk about something called OpenShift. This is also something that a lot of you have probably heard of before. But for those who haven't, OpenShift is more or less the Kubernetes distribution by Red Hat. And it's good, it makes sense. They have a lot of very secure defaults. Like, the last thing that's bitten us in the ass is some SE Linux stuff that popped up in the latest version. So that's obviously good, but it's also sometimes annoying. And there's this certification program. So you can get your operator certified on OpenShift, which is awesome, and which turns out a lot of our customers actually want. So this is the enterprise world that we deal with or live in. So lots of our customers want our operators to be certified. How hard can it be? Well, it turns out it's not exactly trivial again, because of, like, as I said, we started 2020, and the certification process has changed 2 times since then. Like, totally, the implementation and so on. Obviously, the documentation hasn't been updated every time. That would be too easy. That should be a challenge. So that wasn't trivial. Fortunately, the good folks at Red Hat have been very responsive when we reached out, and they helped a lot. But you need to recertify every version of your operator and images. The image certification process works quite nicely, we found. The operator certification process does not work quite nicely, we found. Like, it's running on a GitHub-based workflow where you send pull requests and they fail about 1/3 of the time. And it's getting better, but it's hard. So basically, it's really hard for us to automate our release process because someone has to sit there and click the stupid button to rerun the stupid workflow again until it works. The next thing we learned, all of this is more or less a lie, because all we do is we certify the metadata. It doesn't, like, you can certify a Bitcoin miner. That Red Hat doesn't care. All it cares about is that the metadata is correct, that it appears in their package manager, which is called Olm, which tells you a lot as well. So that's the only thing that matters. So you have to write the metadata, and it gets certified. So in theory, all of this is good, and I like it, and I like some quality. This is what I complained about earlier. We don't have enough quality operators, so I like it. It's just this process could use some improvements. So if you write an operator, either do OpenShift at the beginning or never, maybe. So that would be maybe a lesson. Maybe I should actually say what our lessons were from these things. Anyway, so next up, building a platform. as you've seen, we have these 10 plus operators, and it turns out some of them need to talk to each other, or not actually, the operators need to talk to each other, but the projects or the product that we roll out, like Kafka wants to talk to Zookeeper. I know, it can work without Zookeeper now, that's just an example, but there's dependencies between these things. And how do you model them? Like, what's the discovery mechanism? There's config maps and so on, but what's the standard terminology in there? How do you configure security TLS? How do I know which CA to trust? Or, God forbid, we even implemented Kerberos support for those. Okay, I don't see anyone screaming, running away, but it works. We have an operator, a secret operator that provisions Kerberos principles and mounts key tabs and so on. It's fabulous. As far as we know, we are the first ones to do so. It's not like we wanted to do it, quite the opposite, but some of these tools are what you would call maybe now legacy, and they only support Kerberos as authentication mechanism, and we had to implement and build that, and that was painful. And that was just one thing. As I said, what should our CAD structure look like? So it's common across most operators and so on. And most of these things are kind of similar, but obviously there's always this odd one out. Like most tools are Java, some are Python, and so they don't have the JVM config options. But we want to keep it the same, and it wasn't trivial building them the same, because one of the benefits that Jannik mentioned earlier that we're trying to do is like you don't just download 11 operators and they might work or might not work together. We try to build 11 operators that work together. So you've learned one, you know all of them. They support the same feature set. We even built like a feature tracker so we could like remember, because I'm a bad project manager, I always forgot what we already implemented where. So we implemented something where we can visualize what we implemented in which operator. And that's becoming hard. Also, like going back to OpenShift, so my team already hates me for the OpenShift stuff, and now I tell them to implement some boring detail in 11 operators, and it's like copy, paste, copy, paste, copy, paste, I hate Lars, I hate Lars, I hate Lars. And this is what happens a lot with those things. Again, the Rust stuff helps a lot here because we can extract stuff, but it doesn't go all the way. Some things like, can you update the README to point to our latest thingy? So we templated the README process, and we have templating repositories and Ansible scripts. It's a horrible mess. Don't look at it, but it works. So the next thing, testing. Obviously, we don't do that. That's a bit hard on Kubernetes, so that's an empty slide. Thank you. I hope it was obvious that was a joke and we were trying to earn money. So obviously testing is good, but testing also hard. We run our stuff on various cloud platforms, and cloud platforms turns out they're pretty unreliable. We get random errors basically every night, like spinning up clusters fails for a reason. I mean, obviously we have to pay for all those failures, right? It's not like, anyway. The best things are when deleting clusters fails. Deleting cluster failed, give me your money. Yeah, so that sucks. And then our tests fail, so someone has to look at the things every morning, or Azure running out of resources happens a lot, and it's just, we don't have enough instances and so on. So it's just painful. And we run our tests on AWS, on Google Cloud, on Azure, on Ionos, on Hetzner, and yeah, the other clouds are available. And if there's a cloud vendor here, we'll happily take accounts for free so we can run our stuff on there. Yeah, but it's getting expensive as well. So really, really expensive, because running these Kubernetes tests, like we do mostly integration tests, which means actually spinning up a cluster, running those things. Most of these errors, you must have seen this, most errors actually happen in weird, like non-unit test scenarios for us, like where something just doesn't work together. And for that, we use a tool called Cuttle. I'm not sure if you know this. There should be the logo here. Oh, there we go. It's a Kubernetes test tool, Cuttle, and it's good. And it looks like this. So you can have like a test, a search step. I didn't have enough room on the slides to fit more of it on here. But you can basically set up your infrastructure using YAML, which we all like and love. And then you can have assert steps where you wait for things and fail on conditions and so on. The problem is we often want to run tests with like multiple versions, for example. Like we have 3 versions of Kafka we support and 4 versions of Zookeeper. We want to run them all in combination, and that didn't work in Cuttle. So we had to template our tests using Ansible, which again, you can imagine is not like this, yeah, it gets me into rage mode. Cuttle now implemented something like conditionals, I believe, and the templates might have just been merged a week or 2 ago. I'm not entirely sure, but this is what we do. So yeah, testing good, but testing also hard. So yeah, we'd like to do more of it, but expensive and not nice. So next lesson learned, testing operators, not trivial. And by the way, we try to not only complain, so we also try to provide stuff upstream, and we commit back to projects and so on. So the next thing we learned, and this, I hope there's no questions on this because this is the one I'm least knowledgeable about, but the team wanted me to, this is the one that they most wanted to convey. Stateful sets are broken. So there's like 4 blog posts or things here. This is a proposal from Strimzy. Strimzy actually just moved away from stateful sets. They have something which I've forgotten the name of. They implemented on their own. Yeah, stateful set, why I won't use stateful sets, the set state of stateful pods in Kubernetes. So for those who don't know, there's a few things, a few problems here. One, resizing PVCs in stateful sets, no. Doesn't work. Not, at least not in a nice way. So once you've settled on a size, then you need to, in theory, you need to tear down your stateful set, destroy all the pods and bring it up again. There's workarounds, but they all suck. The next thing is stateful sets work, so I'm not going to go into too much detail here, but they basically assign an index to every pod. So 1, 2, 3, 4, 5, and so on. And I don't know how many people here have written stupid bash scripts to pass out the index from the host name. Yeah, which is just, this is no way to run a proper German business. I mean, that just doesn't, I want like environment variable or something like this. I don't want a bash script like to figure out which index I am. And also if I scale up, an index gets added at the end. Like, so I want a new pod, so it's going to be pod 6 and 7 and 8 and 9 and 10. But now I want to take pod 3 out of commission. Well, sucks to be me because you can't. You can only remove the latest at the end. And that's just annoying. So if you scale down, anyway. So please don't ask any questions on this because I don't know much more, but I know that they suck, at least for our use case. So tool time. So now we learned some good things as well. So there's some really awesome tools out here, and I'm sure I'm preaching to the choir, and you know all of this. K9S, it's an awesome terminal UI, kubectl on steroids, basically. We use it all the time, and it's awesome. Use it. We use something called tilt as well. I don't have time to go into detail for all of them. The clock says I've got 3 minutes left, so and I've got about 400 more slides. So Tilt is a tool that helps you in the process of developing your operators. So you don't have to manually rebuild them, build a Docker image, push it up and restart it. It does all of that automatically. So it monitors your workspace, rebuilds it, and you have a new operator and stuff automatically running. We also use KSVS, a lightweight Kubernetes, 1 binary, everything in it. You can run it on your local machine. Awesome. We like those very much. There's a few more. We use kind, Kubernetes in Docker a lot, so to spin up a whole Kubernetes cluster on your local machine. Awesome. Kubeswitch to switch between Kubernetes contexts because I always destroy the wrong ones. And we also use Dive and a few others, like Dive is for analysis of your images. It shows you where you waste space and so on. We use a bit more, but I didn't want to waste your time with just tooling stuff. So the next thing that we learned is declarative all the things. Like this is a Kubernetes conference, so awesome, yay. But wait, there's more, because there's this thing called imperative actions. Like I want, please raise your hand if you've heard of imperative actions. Okay, well that was a joke because that was my imperative command. Anyway, there are some things, and unfortunately there's no good support for this in Kubernetes. There's this issue, support arbitrary sub-resources for custom resources. It's been open since 2019, because we do have things like /scale, /logs, and so on in Kubernetes, but I can't add a sub-resource /backup or /restart or /vacuum. There's a few things in here at the bottom that, like, sometimes imperative actions are needed. Some things can be modeled in declarative actions, but it's not nice. And now, I won't have time to finish all of them, but this is more or less my plea. It would be really nice if we had more standards, like reusable objects. How do I reference the database? How do I reference TLS thingies, LDAP credentials, and so on? CID conventions, snake case versus YAML versus camel case, thank you, and so on. Naming, all of them are different. Structure, do I have a config level at the top, or is it everything at the top? What kind of features should we implement? There's actually a standard coming up on that from one of the communities for database operators. Like, how do I do discovery and dependencies, pod config overrides? How do I do those? LDAP support, S3, Kerberos, for those unlucky bastards who have to do that. Database connections, TLS, log aggregation, monitoring. We want standards for all of those in CRDs so that they all look the same everywhere, and it would be awesome to collaborate. And this is my plea part of it. And yeah, there's more. I just try to go through this more. So this is almost at the end. We also learned that enterprise shit stuff is much more important than features. So our customers often don't care about a new feature, but they do care about support, well-defined LTS policies, OpenShift certification, air-gapped, regular updates, all this. And now lots of supply chain security stuff. For those who have heard of the Cyber Resilience Act, this is coming up. Yeah. And I've got some miscellaneous junk. I'll skip over this. So the big thing is Java caches DNS hits and misses forever by default, which is awesome in Kubernetes. So would we do it again? I don't have enough time because I want some time. Do we have questions? So would we do it again? Yes. Would we do it differently? Yes. I don't know how, but we would do it differently. Probably not better, but differently. Yeah, so I hope this wasn't too much bullshit. I hope you learned something. Obviously, in 20 minutes or so, we can't do too much details. Yeah. Thank you very much. Questions? Thank you.
Excellent. Thank you very much. It was a laugh and a cry and everything in between.
I only want to answer the easy questions.
Okay, well, then I will... well, then let's start. How many lines of code does an operator have on average? Just say a number.
Not a lot, actually. Like 100, 200 maybe or so. I would say, I don't know, but all of our stuff is open source. Look it up. I could have put a link on it.
You could have put a link on it. But you know, you're not in DevRel, so that's your excuse. All right.
You can ask hard questions as well.
Okay. Do you also have tests for the platform using local clouds like Minikube or Kind? Well, you mentioned Kind.
You use all our stuff on Kind and Minikube as well. Minikube has you need an extra setting because of things, but yes, we've got docs on it as well. Yes.
Someone is very worried if your customers are mad about using. Okay, you can read this one.
Are your customers mad that you do Kubernetes? I'm not judging if they pay me. But yes, some of them probably. And yes, we actually, when we started out, what we did, history lesson brief, what we did is we wrote our own kubelet that ran pods as systemd services. It turned out to be pretty hard, and we abandoned it. But that was the way we tried to combine those two things. So we actually switched halfway through. We worked on this together with the Crusted folks from Microsoft. So yeah, it works surprisingly well, actually.
Right, I like this one. Because apparently people are feeling that you're putting responsibility in their shoes. So if you are the first to write templates operator, shouldn't you
be the first? We have this meeting now. Yeah, actually, that's correct and that's true. And we actually did reach out to Leonard Palke. Some of you might know him already about the CNCF meetup here in Hamburg, and asked him what the best place would be for us to propose those standards. So yes, it's a matter of my limited time, but we would love to collaborate and work on this. So the answer is yes. It's just, yeah, we haven't gotten around to it yet. But yeah.
Yet. Okay. After this conference, maybe.
That's what you said.
All right, one more. How do you benchmark the quality and reliability of your operators? Does the choice of language Go versus Rust really matter?
I'm not entirely sure how to answer that. I don't think it matters for the quality, to be honest. It mattered for us for the speed of implementation. But yeah, you can write good operators in Go and Rust. So if I give the impression, I mean, I was joking a bit, that Go is not a good language, that's not true. For us, Rust was a better choice. It turned out to be a good one. And quality and reliability, I don't know what benchmark we test. And we obviously look at tickets from customers, complaints from customers, of which there are some, but not too many. Yeah, I don't know how else to answer this, but yeah, we test and see what happens, and yeah.
All right, well, go and find Lars and Jannik in the break if you have more questions, because we have a break coming up and a sponsor showcase, and then at 11:35 we're back here. Let's give one more round of applause for these two gentlemen.
Thank you very much.